In this video, we are going to learn that or we are going to calculate the acceleration due to gravity of the moon, and also we compare the acceleration due to gravity of moon with the earth. So first we'll find out the comparison of this one. So what is the formula of acceleration due to gravity, which we learned, that is g is equal to gm by r square. Now same formula if I can use for moon, that will be gm, m suffix is for moon, gm suffix small m, that is the mass of the moon, and rm, radius of the moon, whole square. Now we calculate this one. So before that I need to write that what is the mass of the moon. So mass of the moon, that means mm is equal to 7.4 into 10 to the power 22 kg, and radius of the moon, that means rm, is equal to 1.74 into 10 to the power of 6 meter. So now we'll compare this one. So what you can find from here, gm is equal to, g is universal constant, so it will be same, 6.67 into 10 to the power minus 11 into 7.4 10 to the power 22 divided by 1.74 into 10 to the power 6. So if you calculate, you will get 1.63 meter per second square. Now for the earth, that is meant for g, you can say g is the earth is 9.8 meter per second square, and you can write gm is equal to, as we calculated here, 1.63 meter per second square. So if you compare this one, that means you can write gm by ge, you will write 1.63 divided by 9.8 meter per second square, and also meter per second square. So these two things will get cancelled, it will come 1 by 6. So from here we can conclude that the acceleration due to gravity of moon is 1 by 6th that of the earth. So you can write the acceleration due to gravity of the moon is 1 by 6th that of earth. Okay, so that you can say. Now today we'll also learn some few more informations about the g, the value of the g. So remember that the value of the g, there is a g mm by r square is the formula, and you can also understand the value of the g is inversely proportional to the r square. That means the value of the g on the earth is not constant. Okay, so it is maximum at the pole of the earth and minimum at the equator of the earth. Okay, so first one is the value of g is maximum at the pole, because the shape of the earth, this look like this geoid shape. Okay, so here the radius is more, here the radius is less, so that is why it is happening. So the value of the g is maximum at the poles of the earth and minimum at the equator of the earth. Okay, so you can understand also when r is minimum, then g will be more. If r is maximum, then g will be less. So at the equator, the value of g is 9.78 meter per second square, and at pole, the value of g is 9.83 meter per second square. Okay, so you can write the value of g at equator is 9.78 meter per second square, and at poles that is 9.83 meter per second square. Okay, so next one is the value of acceleration due to gravity decreases with the height. That means if the height increases, the value of g will decrease. You can understand the r value will increase, so g value will decrease. So you can write point number 2, the value of g decreases with height. Okay, and at infinity, the value of g is 0. At infinity, the value of g is 0. Okay, now point number 3, that the value of g decreases with the depth. As we go down below the surface of the earth. As we go down below the of the earth. Okay, and at the center, the value of g is 0. Okay, and you can write, and at the center of the earth, the value of acceleration due to gravity become 0. Okay, so these are the information regarding the acceleration due to gravity, and so you remember the formula of this one, and also you remember the acceleration due to gravity does not depends upon the mass of the falling body, so that the object fall towards the earth with the same acceleration. Okay, so this is the information. So now next class we'll discuss about the comparison between the acceleration due to gravity and the universal gravitational constant. Okay, so today is up to this, so thank you very much.